Hey everybody, Miss Dietrich here. We're going to explore ratios with food, and we're going to start by talking about these packages of oatmeal that we often use at breakfast time. And I used to eat these when I was a kid. And on the back, what I never paid attention to were the directions. Did you know that you can put the wrong amount of water and mix it in with one of these, and it just doesn't come out the way the manufacturer intended? So it's probably a good idea, if you haven't already been in the habit of reading the instructions on the back of these things, it's probably a good idea to start doing that. Because for every pack, right, for every pack, one package of these, you're supposed to put in a certain amount of water. And I'm looking at the back of this, and it's saying that you're supposed to put a half a cup of water. So I'm going to write it as a half a cup, but I'm also going to write it as a decimal because I think that's going to help some of you to realize that there's a pattern here. Right, that's equal to 5/10 of a cup, right? Now, I don't know about you all, but when I had these, I was a hungry girl and one of these just didn't suffice for the day. So I actually used to pour 2 of these in my bowl. So the question is, how much water would you need? Well, let's follow the pattern and keep it as halves. If we keep it as halves, wouldn't we need a full cup, which would be equal to 2 halves? And I'm going to write the full cup up here in blue as a decimal. All right, what if I needed 3 of these to suffice? 3 packs, we pour it in the bowl. So can you visualize that? We pour 3 of these in a bowl. We got to put the hot water and stir it, right? Then that would be how many halves? That would be equal to 3 halves, right? Which would be equal as a decimal to 1 5/10, 1.5 or 1.5. What about 4? 4 of these, how many halves would that be? So follow the pattern. See, 1 is a 1, a 2 is a 2, a 3 is a 3. So 4, wouldn't this be 4 halves? Which would be equal to 2. And we can kind of keep going, right? What if it's 5? 5 packages of these. How many halves? How many cups of water would we need? It would be 5 halves, which would be equal to 2.5 or 2.5 as a decimal. All right, now how can we use this idea of ratios to help us with more complex problems? What if we were going to have an oatmeal party and we decided we're going to use an entire box of one of these, and let's say it has 10 packages, and you wanted to know how much water do you need? Let's look at the different ratios that we have, because this is a ratio right here. Any one of these are ratios, and they're all equal to each other. This ratio, this ratio, this ratio, they're all equal to each other. Now, the one that I personally find to be the most user-friendly is this one right here. Now, why do I think it's the most user-friendly? Because we can rethink the 2 halves as 1. So it's really a 1 to 2 ratio. So let me write that. I'm going to write it down here in red. It's a 1 to 2 ratio. So for cups of water, I'll just put W for water. We need 1 cup of water for every 2 packages of oatmeal. So we can use that to solve problems such as, how much water would you need if you had 10 packages of these? And what's nice about this more user-friendly version of these ratios, and the reason why this is a good choice to pick if you ever have to do problems with this, is because the numbers are compatible and easy to work with. So if we had to figure out how much water, how many cups of water do you need if you have 10 of these, then we would say to ourselves, oh, 2 and 10 are compatible. 2 times 5 would equal 10. So 1 times 5 would give us the answer, which of course would be 5. So if we're going to add that to our table, let's put it in. We need 5 cups of water for every 10 packages of oatmeal. All right, so now let's talk about another thing that comes in packages, and that's hot chocolate. Swiss Miss, they make these. And on the back, it has directions on it. And you probably don't pay much attention to that. I know I never did. But the consequences for not using the ratio that's recommended on the packaging is that you might make your hot chocolate a little too watery or a little too fudgy. Now, I used to like mine really fudgy, but if we look at the instructions very carefully here, it does say, and I'll read it to you, it says that you're supposed to empty contents of envelope into a cup, gradually stir 6 ounces, which, by the way, is 3/4 of a cup of hot boiling milk or water into the mix. All right, so we're going to set up a data table that's similar to this. I'm going to go to a fresh page. And let's make sure we understand how to set up a data table. So let's, I'm just going to draw a line here, and then I'll draw a bunch of lines going this way. All right, and that should be probably enough. So once again, we're talking about packages. So I'm just going to put PK for packages, abbreviate that. And then we're talking about cups of water. So I'm just going to put a C for cups of water, but I'll just kind of down here put water so we know. All right, so according to the packaging, it says for every 1 pack, you're supposed to put 3/4 cup of water. So then that begs the question, what if you're really thirsty, you just shoveled the driveway, and you want to have like a big cup? Like I usually drink my coffee, I usually have one of these. So if we're going to do 2 packs and we want to know precisely how much water are we supposed to put in, right, then wouldn't we have to find what 3/4 times 2 is, because we're basically doubling it. So let's do the computation down here. 3/4 times 2 would be the same as 2/1, and that would equal, we're going to leave it, by the way, as fourths because that'll help us to identify the pattern. We're not going to reduce like we typically do in class, but if we do 3 times 2, that would be equal to 6, and 4 times 1 would be equal to 4. So this is equal to 6/4. Now, could we reduce it? Yes, but we're not going to on purpose to help us see the pattern. So I'm going to write 6/4 here. All right, now if we keep the pattern going, and we're going to, instead, now we're going to go with 3 packs because we are really thirsty from shoveling not only our own driveway, but our neighbor's driveway as well. Let's put the 3 right here. So how many fourths would that be? Now, what's the actual algorithm that you would be doing in that case? It would be to multiply 3/4, not by 2 this time, but by 3. So if we multiply it by 3, then it's my hope that you see that 3 times 3 would be 9, and 4 times 1 would be 4. So that's 9/4. Now, you might see a pattern, and this is the reason that we left them unsimplified, because you may say to yourself, well, to get the numerator, 1 times 3 equals 3, 2 times 3 equals 6, 3 times 3 equals 9. So we could kind of keep going with this idea of fourths, right? We could keep going with the idea of something fourths, and we could keep going with our sequence here. And if we do 4 times 3, so that would give us this number, which would be 12. If we do 5 times 3, that would give us this number, which would be 15. And if we do 6 times 3, we're going to get our pattern of 18, right? Now, if we look at all the fractions that we have here, there's one in particular, this one right here, which results in a whole number, which means that if we have to pick a ratio that's the most user-friendly, that we would use that one. Now, what would this simplify to be? Did you know that 12/4 is equal to 3? So I'm just going to write that over here. That's a 3/4 ratio, 3/4. So that's the same thing as this. This right here, this thing, and this thing are exactly the same thing. Now, the reality is any one of these ratios, any one of them, this one, any one of these, they're all equivalent to each other. And if we were to check the cross products on any one of these, the cross products would match. But this ratio right here, the 3/4 ratio, if we have to use a ratio to help us with any kind of a problem solving situation. So let's say they wanted to know if you had, let's say, 16 packages of hot chocolate, and that would probably be an entire box, right? For most the way these are packaged. And we wanted to know how many cups of water do we need, and we were trying to problem solve, then we would set up a proportion. And we're talking about cups of water, and we're talking about packs of hot chocolate. So I'm going to use this most user-friendly ratio because we need 3 cups of water for every 4 packages of hot chocolate. And we can use that to solve for how many cups do we need for 16 packages, right? Now, why is that the most user-friendly? It's the most user-friendly because, you know, we have a whole number and we have a whole number. It's also user-friendly because 4 happens to be compatible with 16. So we can go ahead and multiply by 4 and multiply by 4, and we can get our answer, which of course would be 12. So we would need 12 cups of water for every 16 packages of hot chocolate, in case we were going to have a big hot chocolate party and pour it in one of those gigantic thermoses. And we even had one that was big enough to hold that many cups, because that's a lot of cups. All right, now I just want to bring up the point that if you wanted to use this ratio on the far left, this one right here, and let's say you happen to like decimals for some reason, and you thought, well, 3/4 that's equal to 75 hundredths. Did you know that, let's erase all this, if you preferred to use that for some reason, and you might prefer using it just because 1 is also a user-friendly number to work with, and now we're talking about it being a unit rate, which is often a good strategy. So if we slip that into this proportion and just use the decimal equivalent, some people like that. Now, if we were to solve for C in this case, we would say to ourselves 1 times 16 equals 16. So what's 75 hundredths times 16? Or if you prefer, what's 3/4 times 16, right? Because that would be the same thing as this. We would still get this same answer of 12. Now let's look at how that would work, right? Because we would simplify by dividing by 4. 3 times 4 equals 12. 1 times 1 equals 1. And 12 divided by 1 equals 12. So my point is that you can choose any ratio you want from your data table, but I like to use the one that's most user-friendly. And in my opinion, this one happens to be the most user-friendly one. All right, now let's look at one more example, another food example. Let's look at stovetop stuffing. Stovetop stuffing. So let me move my picture out of the way. Let's move it over here. All right, now I have my box, as a matter of fact, of stovetop stuffing. Here it is right here. And there's different things you have to put in, but the primary, you have to put in some butter, and you have to put in water, and of course, the box. So our unit, when we're talking about breaking this up as a unit rate, we're talking about how many boxes of this stuff you would put in. So I have one box here, and you're supposed to put in a certain number of cups of water. So I'm going to read to you what it says, but usually on these things, on the packaging, it usually tells you, and maybe you can even see it as I hold it up to the screen. But it does say that you're supposed to put 1.5 cups of water with every pack. Now, we're going to talk about that as an improper fraction, again, so that you can see patterns. That's equal to 3/2, right? We do this times this plus this to get the new numerator. So I'm going to put it in as 3/2. Now, I don't know at your house on Thanksgiving how popular stuffing is, but at my house, it's very popular. And I would never just have one box of stuffing for Thanksgiving, because we run out of it, quite frankly. So I always use a minimum of 2 boxes. In fact, sometimes I use as many as 3 boxes. So let's talk about how many halves do we need cups of water. So again, same deal here. If we take the 3/2 and double it by multiplying it by 2, it's going to help you to see a pattern here. So wouldn't that be equal to 6/2? So that's 6/2. 6/2. So 1 times 3 gives us this 3. 2 times 3 gives us this 6. So 3 times 3 would be equal to 9. Right, so are we starting to see a pattern here? Do we see a pattern? What would be the next one? So if we do 4, 5, 6, how many halves would we have here? How many halves would we have here? How many halves? And again, all these top ones are talking about cups of water. So if we do 4 times 3, we're going to get 12. If we do 5 times 3, we're going to get 15 halves. And if we do 6 times 3, we'll get 18. All right, now, do any of these improper fractions divide out to give us a whole number? This one does, right? That would give us 3. If we do 6 divided by 2, we're going to get 3. If we do 12 divided by 2, we're going to get 6. If we do this divided by this, right, we get an even number. Now, what's the one that's the most user-friendly? Probably this one. Probably this one. Because if we're going to write that as a user-friendly ratio, and we're talking about cups of water and boxes of stovetop stuffing, then I like this 3:2 ratio. 3:2 ratio. these numbers are pretty user-friendly. Now, the reality is you can pick whatever you want, right? If you like, maybe you like decimals and you want to, write that in as 1.5, that would be perfectly fine. 1.5 over 1, you could use that. But let's say that you had to problem solve and we were having, a big feast and you had to serve a lot of people and you went to the store and you bought 10 boxes of this, 10 boxes, and you wanted to know how many cups of water do we need, then you can use this ratio right here, which I'm pulling that from right here, 3 to 2. See, 3 is the whole number to 2. And then we would figure out how many cups do you need for 10. So what would we do? Take advantage of the fact that this is compatible. 2 times 5 equals 10. So 3 times 5 would give you the answer for how many cups, and that would end up being 15 cups. 15 cups of water for every 10 boxes of stuffing. Now, the other thing too that I'm leaving out, did you know that you're supposed to mix butter? And it does say on the packaging, so that's a whole nother, we could do a whole nother data table for that, but we're gonna skip that for now because I think we had a really nice introduction for how important ratios are in cooking. And maybe now you'll start to pay attention more to the directions on the packaging because that will result in your food turning out the way that the manufacturer had intended. So let's start reading the directions and let's start setting up data tables and help ourselves understanding the best case scenario ratios to use in a problem-solving situation. All right, it's been fun working with you all. See you later.